How do we solve that first equation? It's supposed to be super easy on purpose. Dawson, walk us through it though.
Get rid of the 5 on the equation.
Right, how? Be very, very specific.
Use your 5, 6, and 5.
Okay, why are we dividing by 5? So x is b by itself, so the y division. Yes, that, like, oh.
It's multiplying.
Okay, so we're multiplying, so we have to divide. So everybody, how would you describe multiplication and division?
Opposites.
So opposites in math, we typically think of positives versus negatives. We use a different word.
Polar?
It means the same thing that you guys are referring to.
Different.
Different? They're inverses of each other, right? So here we divide because division and multiplication are inverses. So how do we solve this problem? Or really a better question is, what is the inverse of something to the second power, Ellie? So square roots. So let's make a note here, because this is the main concept, is just this one thing. Squaring and square roots are inverses. So that means that actually what we're doing today is not any different than what we've done in the past, because what we said at the very beginning of the year is to solve an equation, you have to use inverse operations. This is all we're doing today, is using an inverse operation. It just looks different, but it's still the exact same idea. So these are obviously not the same problem, but they're both one-step equations to solve, right? Okay, so everybody, what's the square root of 25?
5.
So we get x equals 5 here. Now, plug this back in, 5 squared equals 25. Yeah, that works. Is that the only number squared that equals 25? No. Jack?
Negative 5.
Yeah, so this actually has two answers. Now let's go back to yesterday. We said a quadratic has two answers, right? So this does actually give us x equals 5 and x equals negative 5. Also, to make sure that that is correct, if we used yesterday's topic, that would be move the 25 to the other side, x squared minus 25 equals 0. Somebody raise their hand and factor this for us, Johnny.
X plus 5, x minus 5.
So this is a second way to see that we do end up with the same two solutions here, right? So when you're taking a square root, and we don't know anything about x, right? X is a variable, it could stand for anything. So because we don't know anything about it, we have to take into account that it could be positive or negative, right? So our answer, you can also just write plus or minus 5, because that's easier, right? But you end up with two solutions. Yes?
So, like, if it's just on a math test, like, the topic's irrelevant, and it's, like, find x, and it's x squared equals 9, you could do minus negative 3, and you still get it right?
Yeah, minus 9, yeah. Because then you could, if it was solved using any method, yeah, you could use difference of two squares.
Okay.
Yeah, that will do. So if you're, another way to think about this, just one more way to make sure that we get both the plus and the minus. In true math terms, the square root of x squared, what is the square root of x squared? X, right? So in true math terms, it's actually the absolute value of x, because once again, we don't know if x is positive or negative. So that's another way to think about it. You don't need to write it like this, but I'm just making a note. Because we don't know anything about x, we have to just kind of take care of that. And then if you think about when we solve the absolute value equations, the absolute value of x equals 5, that would be how this would end up. You have to take care of both the positive and negative versions, right? So there's a bunch of different ways that we could describe it, but either way, you should end up with two solutions, which makes sense because quadratics have two solutions, right? So this is the main concept. Riley, what do we do to both sides in part A, and then what do we get?
You do the square root of both of them, and you get x equals negative 11 or x equals 11.
There we go. So we get two answers there, which is good. Porter, what do we do to part B, and what do we get?
So you do the square root of both sides, and you get x equals 9 or negative 9.
There we go. And let's keep going. Sam, what do we do to both sides in part C?
Square root.
Okay, we square root each side. Did anybody, who got 7 and minus 7? How come some of you started raising your hand and then looked around and then change your mind.
I did I added 49 each side,
Okay.
and then I did x plus 7 and x minus 7.
Okay, so if you add 49 to each side, you get a sum of two squares. Is the sum of two squares factorable?
No.
It is not factorable. So you can't factor, you can't solve by factoring because it's not factorable. What number times itself is negative 49?
Nothing.
Yeah, you can't have there are no two numbers that multiply by themselves, or no one number multiplied by itself that gives you a negative, right? So this would be no real solution. We don't get into complex numbers this year, so we're just going to stick with no real solution. If you write no solution or no answer, it's all the same thing, but if you want to be accurate, add that word real in there, because there is an answer, it's just not one that we talk about in Algebra 1. So in part A, what do we do?
Okay, so you plus the 49, so then it's x squared equals 49, and then it's just x equals 7 and x equals negative 7.
There we go. Get the whatever's being squared by itself first. Dawson, how do we get in part B? How do we get x squared by itself?
You divide both sides by 2.
Then what do we do?
Square both sides.
Don't square both sides. Do the inverse.
Square root.
Square root both sides. So x is plus or minus 4. All right, Jack. How do we get part C? How do we get x squared by itself?
Plus 50 divide by 3.
Okay, let's stop there for a second. So plus 50, 3x squared is 48 divided by 3. Okay, x squared is 16, and it actually ends up just the same thing we just did on the previous problem. So square root both sides, plus or minus 4 again. Awesome. Let's keep going. Lily, how do we get x squared by itself in part D?
Add 81 to both sides first. Then
Okay.
divide both sides by 4.
X squared is 81 over 4. Okay, and then, Ellie, what do we do to both sides?
For number 5.
No, part D.
I use square root it.
Square root it. And everybody, what's the square root of 81 over 4?
Oh, 9 over 2.
That's why I chose those numbers. They work out very nicely.
It's
Yes.
so,
So if I factor, and I get the, like, is it okay if I factor, like, I did
Yeah.
2x
So,
minus
guys, lock it up. Yes, you can factor a difference of two squares. You get 2x plus 9, 2x minus 9, and so you get the same answer. Now, if the directions just say solve, great. Tonight's homework, I want you to practice this method.
Okay.
Right? On the chapter 9 test, there's going to be sections for both. I'm going to say solve using square roots, and there'll also just be a solve section.
Alright.
All right, lastly, we want to get the x squared by itself. Hannah, how do we do that?
Subtract 125
And then?
Then you divide by 5.
X squared equals negative 25. What do we do next, everybody?
no real solution.
Yeah, you should, at this point, you can take square roots of both sides, but if you have something squared equals a negative, we can go ahead and stop and say no real solution.
Yeah, what if you put 5?
negative or plus 5 on the test, would that be wrong?
No, because it's the correct answer.
Today? Is it not
No, we are.
homework?
It's just, this will be our another focus tomorrow, or on Tuesday. So, the idea still holds. So you still have to get your binomial by itself, but the previous slide we said whatever is being squared. So if this were a 2 out front, you would divide by 2 first, or if it were a plus 2, you would subtract 2 first, right? So that still holds. You always get whatever is being squared by itself. But now we have something being squared by itself, so then what do we do to both sides to undo a square?
Square root.
We square root both sides. And so then, because these are inverses of each other, right? Something squared and the square root, we know that this becomes an x plus 1 on the left. And then the square root of 4, we now know is, we're going to write it as plus or minus 2. So really we end up with two options here. And so we need to, I would write this in two different ways. I would say we have equals 2, this is 1. And then just like with absolute values, we have a second one, so then x plus 1 equals negative 2. We have to solve these two separate equations, so then x equals 1 and x equals negative 3. So we got two solutions, which we should have expected. We had something squared, but now it's different because they're not just the same thing, right? So we take the square root of both sides, you get 2 out, and you get a negative 2 out, and then you just solve whatever was in parentheses, right? Making sure that we isolate it first. So get it by itself first, take square roots, and then solve it. All right. So this first one, Alex, do we need to do anything before we can take square roots? No. So what do we get?
X minus 1 equals 3, and x minus 1 equals negative 3.
Okay, so we get these two different equations to solve, so then it's pretty quick to see x equals 4 and x equals negative 2. Those are our two solutions there. All right, Aiden, what do we do in part B?
Add 3, or subtract 3 with both sides.
And then,
Take the square root.
and what's that give us?
X plus 3 equals 5, and x plus 3 equals negative 5.
All right, x plus 3 equals 5, x plus 3 equals negative 5. Subtract that 3 over, so we get x is 2, x is negative 8. All right, let's keep going here. Parker, what do we do in part C?
You divide by 2,
Okay, and then
it equals 25. So then you have the square root equals x plus 5 equals 5.
x plus 5 equals 5, and
X plus 5 equals negative.
there we go. All right, so when we subtract that 5 over, it looks like we get a 0, and it looks like we get a negative 10. All right, let's keep going. This one has 2 steps on the on the outside. That's all right. Stuart, what do we do?
Add 1, and you subtract 1 first,
Okay.
and then multiply by 3.
All right, then we multiply by 3. Then what do we do?
Square root of both sides.
Square root both sides, and that gives us
X minus 7 equals negative 3, and x plus 7 equals 3.
all right. So then we add 7. Looks like we get out 4 and a 10. And then one final one. Tyler, what'd you do in part E to get this by itself?
Multiply both sides by 3.
And then what did you do after you multiplied by 3?
I divided by 2.
Alright, so let's multiply both sides by 3 halves. 2x minus 3 squared equals 36. Tyler, what do we do next?
Then you take this side.
Alright, and what's that give us?
2x minus 3 equals 6.
And?
And 2x minus 3 equals negative 6.
Okay, so then we have 2-step equations here, which is fine. We've solved 1,000 of these this year. Add 3 everywhere. And then we'll divide by 2, so 2x equals 9. 2x equals negative 3. Divide everything by 2. So we get some fractions, that's alright. Have fractions as your answers. So 9 halves and negative 3 halves. So I want to make one final comment about this stuff that we didn't. So maybe if we could we'll do a part F together. Probably should have been our part E, but that's alright. Let's just make this a straightforward one. Let's say it's an x plus 1 squared equals 11. So what do we do? Ethan?
You square both sides.
We
I'm sorry, I thought square root.
square root both sides. Alright, square root both sides. Now, do we know what the square root of 11 is? No. So here's what I want you guys to do when that happens, because it's going to happen. You get an x plus 1 on the left side, we know that. Just go ahead and set it equal to plus or minus the square root of 11. Because we don't know what that is, so why don't we leave it like that? Is x solved for? Meaning, is x by itself?
No.
No. So we'd subtract 1 from both sides. So x is going to be a -1 plus or minus the square root of 11. These are actually easier problems because there's less work to do. You can come up with answers faster. This is a very acceptable answer, right? This is okay.